Hello and welcome to the second video in our Twilight series looking at coherence in maths. Today's session is going to be focused on the linear number system and place value. So as you can see, this video forms part of a series of videos. The first video, which we've already had previously, looked at early number and number sense. It focused on the early years and those counting principles such as cardinality, as well as introduced a few key representations that we're going to be building on this time. In this second video, we're going to look to try and make the link between how that early number and counting builds into place value, all the way up into looking at the decimal number system as well. And again, big focus on the key representations and their purpose really in terms of how they're used to allow the children to see the structures of the mathematics that's going on. And they will also be making some links ready for video 3, which will look at additive reasoning. Okay, so just before we start, just to pinpoint a few key documents that a lot of the things in this PowerPoint have come from. So first of all, the DFE document, which looks at maths guidance for Key Stage 1 and 2. So this contains the ready to progress criteria, as well as a number of example assessment questions, and we'll be looking at a few of those throughout the session as well. As always, we'll look at the EEF guidance reports, particularly I've stuck with the Key Stage 1 one for this point, looking at recommendations 3 and 4, but we are linked to the Key Stage 2 maths guidance report as well. And finally, you'll notice a lot of materials in here come from the professional development materials, particularly the first spine, which is around number, addition, subtraction, multiplication, and those types of areas. Okay, so as I mentioned, this one was going to focus on recommendation 3 of the guidance report. So this one's looking again at using manipulatives and representations to develop understanding. There's so many manipulatives and representations out there, particularly in some schemes that you probably use. And this PowerPoint and this presentation is hopefully going to look at how we can use those alongside some language to develop that mathematical thinking. But it'll also look at how these representations talk to each other so that you can make the best informed choice over which representations and which concrete materials that you want to use with your class, which will support the children to make the best learning that they can. And the other one that we'll look at as well is recommendation 4. So this one talks about the importance of assessment and ensuring that teaching builds on what children already know. So with this one, as I said, this video builds on the early number and the work of the early years and Key Stage 1 teams. And a lot of the representations and that learning will have been done. And again, also with a real focus on language from that video too. And it's important that we're following and keeping those structures so that the children become used to those routines and we're able to build knowledge and make links between their new learning and their prior learning. Okay, so this session, as I mentioned, we're looking at linear number system, number and place value. So this has been snipped from the DFE guidance, and these are the ready to progress criteria. So across the top, you can see we've got the years 1 to 6, and then we've got 3 real strands within number and place value. So the first one is looking all at things to do with counting. So for example, in year 1 being able to count up to 100, and then moving on into that understanding of base 10 and that number system base 10, which we're going to have a look at during this session as well. The second row that you can look down, so 2 number and place value. This is looking at the importance of understanding the digits, so we'll focus on place value charts and things like that during this part as well. And then the final one is looking at the linear number system, so we'll develop on the importance of number lines and how they talk to number tracks, and most importantly how you can progress from those number tracks onto those number lines. Okay. Right, so let's get started. So before we really move on, just a bit of a mathematical challenge to get you all woken up into your training session today. So, and also to help us to understand and appreciate just how difficult the base 10 number system really can be for children that are first being introduced to it. So what I've set up here for you, I've got a little place value chart in this top left hand corner. But as you can see, this is working on base 3. Alright, so it works in the same way that you would on a base 10, where you'd have your ones column, your tens columns, and your hundreds column. And we know that obviously the highest digit you could place in any column in base 10 is 9. So within our base 3 here, the highest number you can place in any of those columns is 2, 1 less than the base that you're working on. Okay, so if I look down this left hand side, I've given you a few to get you started. So if I wanted to write the 0, it would be 0, just the same as it is in our number system. And the number 1, we know, would be made up of a single counter in the ones column, so it'd be written just as the number 1. Number 2 would be made up of 2 ones, so it'd be written just as the number 2. Now this is where it starts to get a little bit trickier, and this is the understanding that you really need to realise how difficult it can be for those children. Because now to write the number 3 using our base 3 system, I need 1 3's counter and no 1's counter. So the number 3 is written how we would write it, as a 1 0, a 10 in our number system if you like. Okay, and the number 4 would be made up of a 3's counter and a 1's counter, making the number 11. So let's have a go at feeling what it's like for a child who's new to this number system. And I want you to just pause this video and have a couple of minutes just having a look at how you would write 5, 6 and 7 using our base 3 system. And then we'll come back together and look at that. Okay, so hopefully you've started to spot a little bit of a pattern, and that's the way we like to talk about when we're thinking about variation, procedural variation, and also trying to draw your attention to things. So the number 4 was written using 1 3's counter and 1 1's counter. The number 5 would be made up of 3 and 1 and 1. So it'd actually be written using the digits that we would use as a 1 and a 2, like the number 12. Okay, so let's have a look at that. There it is. So 5 will be written as a 12, and then hopefully you understood and managed to get to the fact that the number 6, oops, got too far. The number 6 would require 2 3's counters. So a 3 and a 3 to make the 6, leaving you with a number 20 there. And then to make 7, you'd need 2 3's and a 1. So that's where you end up with that 21 there. Okay, and then for the second part of the challenge, you can see just how confusing it starts to get when we move into 3-digit numbers there. So for example, the number 9 being made up of a 9's counter with no 3's counter and no 1's counter, and so you'd end up with the 100 that's going on there. Now for us, obviously that's a little bit abstract anyway, because base 3 isn't something that we're particularly used to. But the point that I'm trying to illustrate here is just how difficult the base 10 number system can be for children that are new to it, particularly those who have been taught to rote count, that can count all the way up to 20 really confidently. Actually then starting to build and see why those numbers represent 20 can be a really challenging step in their learning, and it's something that I think it's so important all the way through their development of number, and it's something that we really need to make sure we emphasize as we go through, and hopefully we'll look at that as we go as well today. Okay, so just pulling out just one part from the guidance report. It just refers to the idea of what pupils should be able to do. I'm just going to leave you to read that slide for a second. So that statement just comes from the Year 1 guidance report, and already you can see the complexity that's coming out in that. So an understanding that 42 can be 42 ones or 4 10s and 2 1s. So all of a sudden, we've now got 2 different ways of thinking about the same number, and how challenging, how difficult that can be if children aren't ready for it. And if they haven't had that understanding and that chance to be exposed to partitioning and combining numbers and seeing how numbers can work together, for example, when they're partitioning single digit numbers, knowing that 8 can be split into 5 and 3, then they're not going to be ready for the idea that you can write a number in 2 different ways. And we've got talking about here grouping, understanding of equal grouping going on, the idea of different objects. So that links to a concept called unitization, which we're going to have a little brief stop off into as well. And also understanding that sometimes there's going to be leftovers when you make groupings. And that's another really challenging part of this concept. As I say, can't overemphasize the importance of children having a solid understanding of the number system. So I briefly mentioned unitization just on the last slide. So unitization is really what the Dean's rods are trying to work towards. So you can see that they've got this almost arbitrary rod here, and learning that represents the number 10. And then that this represents the number 1. And that's an example of unitizing. There's no reason why later on, so for example, when we move into Key Stage 2, some Key Stage 2 teachers might still be using Deans, but into decimals. And actually this is representing 0.1, and this is representing 0.01, a hundredth. thinking about that 100th square. And that's all from this idea of unitisation, and it's another really big concept, getting children to understand that objects can represent different numbers and even more than one number. And those objects don't have to be those mathematical representations such as Dean's. You can see we've got sticks over here, bundled sticks into tens and ones, and some of the best outdoor learning I've seen has used actual sticks. They've been out and collected and made them together as a class. You've got pencils over here which could be used in representations, and I'm sure if you start thinking about it, there's lots more of representations you might use. So for example, coins are obviously a really simple one that children need to be aware of as well, easy to get hold of, but it could be anything, any cubes that could represent anything, and it's that concept of unitisation. Okay, so once children start to understand that different objects can represent different numbers, then we can start to look at some variation in terms of how we might assess that understanding as well. And the one I want to draw your attention to, and I took it out of the first slide that looked at the Ready to Progress criteria, but there's a really good link between measurement and your number and place value system, and we'll keep making that link throughout this session today. So first of all, if I look at this boat at the bottom, you can see it's been measured using those Dean's rods. And that's a really great experiment that you can do, or investigation you could do with the children. Obviously, you've got the tens and ones going on in the top again, using money. And these are different ways that we can try to make links between the curriculum as well, and try and shorten the curriculum down in terms of not making the children, not shorten the curriculum's the wrong wording, but in terms of making sure the children make links between different areas of the curriculum. Because we know those mathematicians who can make links between the concepts are the ones who have that greater depth of understanding, and they're the ones that go on to do better throughout their school careers. So it's really important that we try to interweave these, and actually interleaving the measurement is a really good way, particularly with our curriculum being as full as it is, and the time that we sometimes lose towards the end of the year when measurement comes up. Okay, so next little key representation I want to talk through today is place value charts. So I've got 3 different place value charts down on this left hand side here, and you can see I've just talked about them in 3 different ways, and there's nothing wrong with any of these place value charts, and it's really important again that children are exposed to them in lots of different ways, because actually the top one, which looks at using their nouns, is really important when getting children into it the first time, but at the same time being able to see it with numbers or even fractions in the bottom place value chart, understanding and making tenths and hundredths, is another way that they need to be able to see it. Now, it's all about what you want to draw attention to at the time, and you'll notice as well I've purposely not colour coded my place value charts. Again, colour coding is a great way of drawing attention to certain things, but it's what's the purpose of that you're trying to do. So for example, if I was to colour code my thousands into one colour, into blue for example, and then if I was to colour code my hundreds, tens and ones all into the same colour, reds for example in this one, and then trying to support the children to be able to read along a number. So for example, if I put some digits into this one, and then using my blue, I'm teaching them that we read the thousands first, and then we read our hundreds, tens and ones, which are our ones group, if you like. So you've got 4,214, and it's another way of just using colour just to draw attention to a certain thing. Okay, and one of the points that I'll keep coming back to and talking about throughout this session is the fact that every representation that you're choosing, you need to have really thought as a practitioner what the purpose is of that representation. So what is it doing to support the children's learning? It's not a case of just using a variety of them, because that can be more likely to lead to confusion than it is to link in those core concepts. So if you're using a place value chart, why have you chosen that? What does that add to your learning? Okay, if you're using tens and ones sticks that you've made from outside, what was the purpose of the tens and ones? Why have you used that? Okay, and then again, place value charts can be used in so many different ways as well. So you can see I've got a little picture over here on the right hand side. I've got a number, purposely done in a strange way here to draw a misconception as well, because when you early introducing children to Dean's, you're likely to see them find their 2 ones and their 4 tens and end up with the number 24 if we're not really careful about that. Okay, so as we're putting them into the place value chart, I might tick them off as we go. So I can see that I've got 1 1 and 2 ones, and I could use pictures for this one. So for example, I could just draw some dots in there. I could draw some ones counters. I could write the digit. all of those would be different ways of being able to look at this same concept. Then with the children, I might just early on get them to double check these Dean's rods so they understand and they can unitize them, so they might want to count each one down. But normally by the time we're at this point, they understand and have learned to unitize that this is a tens rod. So then we can count our tens. So we've got 1 10, 2 10s, 3 10s, 4 10s. And again, we can put them in. I could use dots for it. I could use tens counters. I could use the digits. Again, all are perfect in that way. So now we can see that, again, focusing now onto the language, that I've got 4 10s and 2 more 1s. The number I've got is 42. And you can see how the place value chart has helped us to then link that concrete resource, or pictorial in this case, but normally concrete resource of the Dean's rods, to be able to build and create those numbers on. Okay. I'm sure place value charts are something that you've used a lot, but again, just making sure that as a school you've understood and decided on how you're going to use each one, why you're moving between the use of nouns, letters and numbers, or even fractions, colour coding and its purpose, and not necessarily just saying we've got one set that we've laminated and this is the one we use for this reason, because actually the representation might need to be slightly different in order to unfold the right structure in the maths for those children. Okay. The other really good thing with the place value charts is to introduce the idea of scaling. So multiplying by 10, 100, 1,000, dividing by 10, 100 and 1,000, multiplying by a tenth, which is a concept that in year 6 it can get really confusing as well. And actually, if children have got a really good understanding of how the place value chart works, that's when we can start to use it as a really good tool in terms of multiplying by 10. So quite often I'll see in schools where they talk about, for example, if they had the number 3 and if they multiplied it by 10, they move the digits all one place to the left and then they put their placeholder in there. It's a next step up from saying add 0. What does that actually mean to the children? Do they understand that when my 3 1s has moved into 3 10s, it's because it's been increased by that scale factor of 10. It's got 10 times greater as a number. And when they've got that understanding of how that place value chart works in that way, then they'll have that breakthrough into terms of why multiplying by 10 works like it does. And that's the reason why we get into Key Stage 2 and we start to see them using decimals, and all of a sudden we can't multiply by 10 with a decimal because actually they've learned put them digits to the left hand side and put a 0 in, and then when you take away that scaffold of the place value chart and they've just got the number, you end up with your 0.1, putting the digits to the left hand side, you still end up with your 0.1, and then they put their 0 on the end and they still end up putting their place value dots into all sorts of different places as they do it. So supporting them to understand exactly how that place value chart works. Okay, next little representation. So this representation comes from the first session as well, where we really had a big focus on the importance of 10 frames and why 10 frames are an essential key representation that we want children to explore and to use. You can see in this video I've got 3 different tens frames here, and they're all doing exactly the same job. They're supporting the children to understand that the unitization, that when I reach 10 of something, it's equivalent to 1 of something else. So in the first one, again, that really clear, concise generalization, 10 1s is equal to 1 10. And I can see that by counting on it. So in this case, I've just put 1s in there, but you could be using place value counters, you could strike through them as you count them, anything along those sorts of lines using that 10 frame. I've seen it done at Christmas using baubles, which was good to use, again, just using that unitization to try and make the purpose of the lesson. So 10 1s is equal to 1 10, so we could do 1 1, 2 1s, 3 1s, 4 1s, 5 1s, 6 1s, 7 1s, 8 1s, 9 1s, 10 1s. 10 1s is equal to 1 10. You notice that really concise language that we were throwing in there. Okay, if we look at the next one, so we now have got 10s in each of these 10 frames. And now again, this can be a little bit trickier in terms of your counting, because you've got 2 different ways you might count this one. So for example, to match with the language focus and that really clear generalization that I'm looking for, I'm going to count them as 1 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, 8 10s, 9 10s, 10 tens, and then as a class we can pause. What's our generalisation? 10 tens is equal to 100. And that's really important, that they're unitising each of these as a 10 instead of just skip counting in tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Because actually the concept I'm trying to uncover using this 10 frame at this point is that 10 tens is equal to 100. Okay. And at the bottom you can see we've got 2 language focuses on here, because it's really important that the children are learning to understand that it could be 1-1 and it could be 1 whole. But again, it's that importance of counting. So I'm not counting this one at this point for this concept as 0.1, 0.2, 0.3, because that's what's likely to lead to the 0.10 misconception. What I'm doing here is counting it as 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. I've now got 10/10. 10/10 is equal to 1-1, or 10/10 is equal to 1 whole, which will cement that link to fractions as well. So again, it's about the purpose of what you're using it for. You could use this tens frame for general counting as well, but not if the purpose of that lesson is around making sure it's equivalent to 1-1 or equivalent to the 100. So really thinking about the purpose and the language that fits with it. And the language focus, the STEM sentences, if you like, generalising them as a school and as a cohort, as year groups, to make sure every child is using the same concise generalisation will really support them with their learning. Okay. So carrying on, just looking at tens frames, just again, this is back into year 2 focus. So this is looking at the idea of 18 tens and starting to go beyond 100. So exactly the same as what we've got last time. So if I was counting it, I'd be looking at 1 tens, 2 tens, 3 tens, 4 tens, 5 tens, 6 tens, 7 tens, 8 tens, 9 tens, 10 tens. Oh, it says tens there, but 10 tens is equal to 100. But then I've got some more tens. I've got 1 10, 2 tens, 3 tens, 4 tens, 5 tens, 6 tens, 7 tens, 8 tens. I've got 10 tens and 8 more tens. So I've got 18 tens is equal to 10 tens and 8 more tens. 10 tens is equal to 100, so 18 tens is equal to 108 more tens, which is 180. Now that seems quite a complex use of language, and it will soon shorten down, but the reason the NCTM have pulled towards that one is to really start to cement that importance of counting up to those 10 tens. And then again, soon unitisation will come, and a lot of the children by this point as well will have already started to see this, so they already know that they've got a 100 here, and they will start to say, well, I've got 108 more tens, because they can see that the 10 frame is full. Just like the importance of subitizing that we talked about in the early years session last time as well, a lot of the children will already have seen this as 5 tens and 3 more, and wouldn't need to count them in that same way. They'd be ready to move on at the right time. Okay. Now just focusing just on that little session that we're talking about here with the 18 tens, again using the importance of that tens frame would be a really good representation for this. Just wanted to look at a little bit of procedural variation, so how we could use variation to really cement that concept around the number of tens and the number that they equal. Okay, so what I'm going to do here is try and draw your attention to a bit of a pattern using this set of numbers on the left hand side, and I've used the STEM sentence from the previous one. So you can see that I've talked about 8 tens being equal to 80, 9 tens being equal to 90, and then we might say to the children, how come there's an 8 in both of these numbers and a 9 in both of these numbers? And that's then making that link back to our place value charts from earlier, that tens and ones. So then I've got 10 tens here, but my number only starts with a 1. And then I could have a talk with the children about why it's only that 1 there, and hopefully they'll spot that actually it's because 10 tens are the equivalent to 100, and because of my base 10 system, I know I had to exchange into that next column, which is why I've got my hundreds, tens, and my ones this time. And then I might say, okay, well, what do we notice this time? And I might silently draw attention to it this time and talk about and see if the children have noticed that part there. And then same again, I've got my 12 tens and my 120. And we're just trying to get the children to start to spot that, because that's also then going to support them when they come on to scaling by 10 as well later on in the curriculum. Equally, you can see in my second part of my activity over here, I've reduced the language down, still drawing attention to those same numbers, so that I can try and support the children in noticing that pattern spotting. And then I've got a third little activity here which looks at multiplication by 10. So making the link to the fact that when it's base 10 and we're talking about them being in the tens column, each of them has been scaled by a factor of 10. I'm introducing that concept of multiplication in there at the same time. Okay, so at the bottom I've just picked some more numbers, and I just want you to have a look at that and see what you notice about them, see what the purpose is, how might you use that activity with the children, and particularly how this one over here, 49, 50 and 51, what that might expose in terms of any opportunities for misconception or draw attention to anything a little bit different. Okay. Let's move on again. So still carrying on tens frames. So we talked about tens frames and how important they are in the early years and in Key Stage 1, but actually this is now looking at upper Key Stage 2 here and introducing the idea of hundredths into these. And again, if we have got children to a sound understanding of how a 10 frame work, we've got children to that understanding of base 10 through their place value charts, and we've got them to the understanding of unitization, then this becomes a really smooth step in their learning. But if they've got a gap in one of those because the coherence across the curriculum isn't quite there, then that's where children will start to find this a little bit trickier. If I draw your attention just down to the language focus as well, you'll notice how it's exactly the same STEM sentence that the NCETM have provided on this one as what they had in the previous one. So 18 hundredths is equivalent to 10 hundredths and 8 more. It's that 10 and a bit principle, and that 10 and a bit principle is something the children were first introduced to right back in reception in year 1 when they were looking at numbers greater than 10. Just like they looked at the 5 and a bit principle in order to subitize the 5 and the 3. And it's that same concept being referred back to again. The only difference now is that we've looked at unitizing, so we're in a slightly different place value column. Okay, next representation I want to take you through. So this is called a Gattegno chart, and I'm sure so few of you have probably noticed these come up before. And I'm sure some of you have probably done the same as I did the first few years that I saw this and skipped it because I didn't really know what it was or how it worked. So hopefully I'll help a few of you out here. This is really good at exposing what happens during the count sequence. But again, when it comes on to multiplying by 10, scaling, it's hundreds and thousands, or by tenths, this becomes a really useful chart and representation, but only if the children have been exposed to it from early on in the school. So how it works, really simple. I'm just going to take you through a few examples of counting. So the Gattegno chart, you could use a counter, you could use a highlighter, you could use whatever your pointer might be. So a massive pencil mine used to be. Some people use a wand. I've seen lots and lots of different ways of doing it. But all we're doing with the Gattegno chart is moving along. So in this case, early introduction, it looks more like a number track. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Really simple. Now when we go over to the number 10, we've got that next part. So first of all, I'm just going to skip counting tens and make the link to the number track. It can work in exactly the same way. So the Gattegno chart then links the two together. So for example, if I was counting from 8 here, you can see the 8 is highlighted, the 9's highlighted. I then cross into the next place value column, the 10 is highlighted, but then the next number, the number 11, is made up of 10 and a bit. So you got my 10 and my 1 to make 11, 10 and 2 to make 12, 10 and 3 to make 13. And so it's just exposing children to that count structure. Okay, exactly the same if we were to go for a slightly higher number, so 35 being made up of 30 and 5, and then the counter would move along 36, 37, 38, 39, then the 1's counter might disappear to put the 10's counter across to 40. Okay, so that's the Gattegno chart, and as I said, later on throughout your curriculum this becomes another really useful chart, but only if they're introduced to it from early on in Key Stage 1. Something to have a little think about at school in terms of your policy, your calculation policy, your curriculum, where this chart might appear. Okay, and as I said, this goes right the way up. So now we're looking at it in terms of counting in decimals, counting in fractional steps, would come along those same lines. This language here of 0.03, again, this exposes it really well, but it is another potentially tricky point going on here. So we know we've got our 0.03, 0.04, 0.05 and so on. But then once we reach the 0.09, we know the next thing that children are expecting to themselves to say would be 0.010. So it's about making sure we understand that, oh, what happens when we reach 10 hundredths? 10 hundredths are the same as 1/10. It moves up to the next column. What would happen next then? 11 hundredths. Well, 11 hundredths would be made up of 1/10 and one more hundredth. Okay, really important, that. Really good representation to show that part happening. Just make sure that you're only keeping one number on your Gattenia chart at a time so that the children can see it really clearly. Okay. Again, moving on to another model, another representation that I'm sure you will have used throughout your time. I just want to draw attention to how it could be used to make links between other representations as well. And again, draw you back to that really important language structure because there's potential for misconceptions if children aren't exposed to the right language at the right time. So in this one, we've got the number 28. And as you can see, the number from the language focus, the number is 28. The 2 shows we have 2 groups of 10, okay? 2 groups of 10. Now that phrasing is really important, not just knowing it as 20 and 8, but as 2 groups of 10. The 8 shows we have 8 extra ones. So 2 10s are 20 and 8 more make 28. And that's how I end up with the 28. And that real purposeful language is hopefully designed to stop us from getting some of the misconceptions, which I'm sure you've seen around the number 208 appearing here because you've got 20 and 8. Or for example, the being partitioned into 2 and 8 because you've got 28. Those misconceptions come from a lack of understanding of what the place value is showing you in that chart. And that might mean then that you need to take children away from that part whole model for a little bit and back into a place value chart or back into a Gattenia chart or one of those other representations that we've looked at. Okay. The place value chart, the part whole model also works really well with the bar models because they both identify that part whole structure. So you can see the 28, the 20 and the 8 in exactly the same way. And this partitioning is also supporting children to understand the value of each digit in their numbers. And is also, as I said, alluding to what's coming in the next session. If children are understanding partitioning through the bar models and the part whole models, it's going to really support them when they come to looking at additive facts and writing those addition and subtraction statements as well. So a little challenge here. So this is pulled from, again, from the DFE guidance material. So this is an example of an assessment question. So what I want you to do is just have a little bit of a time, just as a team, and just analyse how does each of these questions change slightly? What are they trying to draw attention to? And what misconceptions might they be trying to expose? Okay, so hopefully you had a good conversation during that pause point there. So if we were to just draw attention to a few things that you can identify from it. So the first one, if we were to look at the first question, that one seems quite straightforward because you've got your hundreds, your tens and your ones. But if we were to look at the next one, you can see you've ended up with your ones, your hundreds and then your tens. So it's trying to draw attention to children to assess that they know that the hundreds has to come first and then how that hundreds combines with the tens and the ones digit. So we don't end up with some numbers such as 3, 8, 0, 0, 20 or anything along those lines that could well become one of their misconceptions. Same with the next one, we've got the hundreds, we've got the tens, but this time it's switched it, so the ones digit they've got to find and bring down into their part whole model. The next one builds on it again, so this time it's the hundreds digit they've got to find that's different, but what they've done is move it so that the hundreds digit is in the centre. Again, just that subtle difference to add that extra layer of challenge. And then in these last two, we've got a 3-digit number that's only been partitioned into 2 parts. So can the children identify how those numbers would go together as well? So it's that real purposeful choice of question to try and assess the children, identify those real clear misconceptions so that you can understand where you need to adapt your teaching, where you might need to put that intervention in. These these assessment questions are really useful checkpoint materials. You could add them in regardless of what scheme you're doing. You could add them in at the end of units as a really nice diagnostic assessment for you and the children. It might even be that you use it as a space practice question that you do at the start of a different session when you're moving on to the next unit, just to see if those children have still got that understanding of it. Okay. Moving on to the linear number system now then. So we've talked about reading and recognising the digits. We've looked at lots of different representations. So now we're going to be starting to look at a final representation, which will be the number lines and how they build on from the number tracks. And I just pulled this little statement out. So this is from the year 1 number and place value ready to progress criteria, and this part in the number 1 document, what you get year 1 document, what you get is where the key learning point is going next, so the reason why this is an important concept, but also what they should already know in order to be able to access this lesson. And this particularly in those schools where I've got disadvantage and high levels of disadvantage, playing games that involve moving along a numbered track. That's something that is disappearing more and more from the society. Games like Snakes and Ladders, for example, and those understanding that of how a number track works that used to come from those games. And I mentioned in the last session a current research project which is looking at the use of those board games as an intervention for disadvantaged children, something to have a look at, but also the strict parameters that it needs to carry on in that linear fashion and not jump vertically. So Snakes and Ladders is great as long as you're only paying up to 20 on a straight number track, so it doesn't really work for that bit. Okay, so number track, just to in case anybody is missing what I'm talking about with a number track, this is just a quick example question from year 1 in terms of filling in the numbers in the number track. So you can see within a number track that the box represents the number. Unitization again, the box represents the number. So where I take us onto here, I've got a number track at the top, where the number 1 is this area here. The number 8 is this area here because the box represents the number. However, if I was to look at the number line underneath, the number 1 is represented by this interval here. The number 8 is represented by this interval here. So it's moving and it's thinking about this data, the number system, in a continual linear fashion rather than as a discrete standalone number in that top one. And it can be a confusing concept for the children and it takes a little bit of time. But what's really important is that you don't allow them to put the number 1, which is a different colour, don't allow them to put the number 1 anywhere in that part because that's then going to lead to problems later on down the line. So be really specific about it when you are moving them onto those number lines. And again, it's another thing about just exposing them to these structures early on. Now, one of the points that I think I'm trying to hammer home again is the idea that the representation should be right for the key learning. So if you could have a little look at number line number 3 for me. Number line number 3 looks a bit strange because of the numbers it's got on it. What might be the purpose of that number line? So just pause the video again for a second, have a little talk as a team. What's the purpose for that number line? What type of learning might that be trying to help? Okay. Hopefully you bounce lots of ideas around there. The whole purpose of this number line has been scaffolded to support counting backwards. Okay, so for example, if we're starting from the 100, it's given the 99 to support that change in boundary. And then we would carry on counting backwards. Same when we get to the 90, it's given us the 89 to scaffold that change in boundary. It's the purpose of the question. And then the next one, we've got this time, we've taken the intervals away, so almost like a scale now. So can the children work out those midpoints? And we're going to talk about midpoints in a little bit more depth and why they're so important in a second as well. Again, trying to support the purpose. So here I've just got, again, a couple of examples, and I picked these ones just to draw attention that these example questions, assessment questions, are from the year 1 curriculum. Okay, so they're quite challenging for a year 1 in terms of where they've got to get to. We've got all sorts of things in here. Estimation, for example, knowing between the 10 and the 20, and that's where the idea of that midpoint becomes really important. And actually, learning that the next question down might be a helping point for them for the next one. So can they mark the midpoint? Then can we estimate from there? So I mentioned about midpoints just on that part, and midpoints become something that's really important when we move on to concepts throughout later school as well. So at first you look at it, and actually children, for example, on that last question, they might get the estimate right, but not be able to explain to you why they've got it, or they might talk to you about how it might represent the number 12 or number 13 because it's closer to the 10 than it is the 20, which is good reasoning. But actually we want them to take it to that next layer to understand that it could be 12 because it's closer to the 10 than it is to the midpoint. The midpoint is 15. The reason why that's important is because then we can support estimates with that later on. We can support rounding because that midpoint becomes so important as well. And it makes that really tricky concept. Anybody who's been in Key Stage 2 and tried to teach rounding, I'm sure you're nodding along, a really tricky concept, a little bit simpler. Okay, so this one here talks about the midpoint at the bottom, that language focus then. So A is 5 because it is halfway between 0 and 10. So it's a really nice STEM sentence. Again, build it into your calculation policies, something to look at right from year 1, year 2, when they're first introduced to number lines. Can they find the midpoint? Can they plot the midpoint onto it? Okay, then you can see that next layer of reasoning I just mentioned. So B is 12 because it is 2 more than 10. So this number line's got the intervals, so I can find that it's 10. I don't need to count from the 0. I can see it's 10, and then I can count on 11, 12. That's why it has to be 12. Okay, same again, they could identify the midpoint and say that it's also less than the midpoint and count back if those intervals weren't on there, but they can see and use those different structures on it. And then 20, C is 19 because it is 1 less than 20. So really trying to get the children to understand that they can work backwards on that number line as well as starting at 10 and counting on. So can they count back as well as count on? It's that idea of efficiency to support fluency. Okay. So as I mentioned, Key Stage 2 teachers will be hoping that Key Stage 1 can get that midpoint learning in well cemented, because it becomes a really important key part of rounding, being able to identify previous to next multiples, being able to identify midpoints in there. Okay, so again, we've got 2 number lines on the left hand side, and just drawing attention to how they're different for the purpose of the learning. Okay, so the first one is looking at how we might identify multiples of 100. So it makes sense that we use a number line that has the multiples of 100. The one below is looking at multiples of 10. So again, it makes sense that the number line has the intervals in multiples of 10. The purpose of the learning. It's not about having one set of resources we can continue and roll out. What's the purpose of that resource and what's it drawing attention to? And then this is just an example. We're not going into rounding during this session. There's an example over here of how you could use that number line to support rounding. So identifying the nearest multiple of 100. So we know that the number 681 is between 600 and 700. So I can fill in that I've got my multiples 600 and 700. Then I can identify my midpoint. The midpoint between 600 and 700 is 651. 650. 681 is greater than 650. So 681 is closer to 700. And you can see if we can identify those multiples on that number line, we can identify those midpoints, we can really support them to reason about their rounding. Okay, final little sort of part, and I mentioned about how we want to try and link areas of the curriculum as we go through. So this is the idea of estimation that's coming in here. So I just want you to have a look at these 3 questions and how this is built, and then ask you the same question, well, not the same question, but which year group do you think this assessment question came from? Okay, so just bringing that into that little pause point there. So this one, again, it's from a year 1 question. It's a really challenging one, but actually when you think about it, all we're doing is that idea of the midpoint. So we've got our 0, we've got our 10, we can estimate where the midpoint is, we know the ruler must be less than 5. And it's that understanding and that reasoning that children need to be exposed to. But as I said, if we're thinking forward, this is a really useful way of introducing the rulers for measurements. It could introduce the idea of using cubes to measure. And again, the children would go around with their 10 centimetre strips, and a great lesson out of greater than or less than 10 centimetres, who can find something that is exactly 10 centimetres, and just being able to give that opportunity then for the children to learn and be exposed to the idea of measurement, whilst also thinking about that linear number system, making the link between their number lines and their rulers and their measuring strips. Okay, and this is a year 2 assessment question, so this is just where it moves on just a little bit. So again, you can see now that the numbers have changed and the idea is still there, though it's exactly the same. So we've got our measuring strip, but it's 100 centimetres now. What do we think line A would be? Well, line A looks like it's the midpoint. The midpoint of 100 is 50. Midpoint is becoming a really important part again. Okay, and final slide for today's session, just again wanting to make that link between shortening links in the curriculum. So we talked about how units of measure might come into this, how data handling could come into this. These are all examples of number lines, but they're being used in slightly different ways. So we've got vertical number lines going on using our units of measure. We've got vertical number lines going on our bar chart, so we're trying to expose the children to data handling. And we've got this scale reading here, which is still a linear number line. It just looks in that slightly different representation. So one of the best ways of being able to make those links between the curriculum would be using things like this whilst you're teaching your number and place value system. So something to go away and have a little look at as you go through your number and place value unit. Where do these opportunities present themselves? Does your curriculum, your resource, your planning support, whatever it is that you're using, does it draw these similarities in? Does it link these concepts for you? Or is it something that you could add in there in order to support your children develop that link of understanding? Okay, thank you very much for joining in today's session. This was, as I mentioned, the second video in our series. So we've now looked at the principles of early counting and early number. We've looked at the key representations that you might use when we're thinking about number and place value and that linear number system, going into decimals. And in the next session, we're going to look at additive reasoning. So we'll be looking at the importance of addition, number facts, and a very, very brief look at the algorithms in addition and subtraction. Thank you very much.